Welcome to Cosmos in a Pod. Ready for some more astronomical adventures?
Always.
Today we're taking a deep dive into binary star systems.
Oh, yeah, these are so cool.
So when we look up at the night sky, we see all these twinkling stars.
Right.
Are most of them doing their own thing, or are they hanging out with a partner?
Actually, most stars out there aren't loners like our sun.
Really?
Yeah, they've got a companion star. They're locked in this gravitational dance, swirling around each other.
A cosmic dance.
Meh.
I like it. So these are binary star systems.
Exactly. And these systems are more than just two stars hanging out nearby. Their relationship impacts how they live, how they evolve, even how they die.
Okay, I'm already hooked.
Mhm.
So if these stars are so far away, how do we even know they're pairs? Can we actually see?
Ugh, those are the tricky ones. But astronomers have some clever tricks up their sleeves to figure out if a star has a hidden companion.
Okay, spill the secrets.
One way is through spectroscopy. It's all about analyzing the light from the star.
Right, because light tells us so much about stars.
Exactly. So as these stars orbit each other in a binary system, they're constantly pulling on each other. That causes a tiny shift in their light, kind of like a cosmic Doppler effect.
Ah, like when an ambulance siren changes pitch as it drives past. So we can detect those tiny shifts in starlight.
We can, and that tells us there are two stars there, even if we can't see them individually.
That's incredible.
It is. And then there's another cool phenomenon we can observe: eclipsing binaries.
Ooh, tell me more about these.
So picture this from our view on Earth. One star in the binary passes directly in front of the other.
Like a mini eclipse, but happening light years away.
Exactly. And as one star blocks the light from the other, we see a dim in the overall brightness of the system.
So we're basically watching a stellar shadow puppet show.
Pretty much. And by studying those dips in brightness, astronomers can figure out a lot about the stars, their sizes, their masses, even their temperatures.
Wow. So we've got visual binaries, spectroscopic binaries, and eclipsing binaries. Are there even more types?
There's one more: astrometric binaries. These are the systems where we can only see one star directly.
So how do we know it's a binary?
Well, that visible star has a little wobble in its motion, like it's being tugged around by an invisible dance partner.
A cosmic waltz with a hidden partner. That's a great image. But I'm curious about how these binary systems even form in the first place. Do stars just bump into each other and get stuck?
It's not quite that simple. It all starts in these vast clouds of gas and dust, the stellar nurseries where stars are born.
Okay.
Now, as this cloud collapses under its own gravity, sometimes it doesn't just form one star. It can actually fragment, splitting into multiple clumps.
So it's like a giant cosmic cookie dough breaking apart to form multiple star cookies.
I like that analogy. So each of those clumps then collapses further, and boom, you've got a binary system.
Cool. But you said sometimes it fragments. Does that mean there are other ways binary systems can form?
You bet. Sometimes it's more like a cosmic meet cute.
Oh, wow.
A meet cute, like in the movies. So two stars might form independently, minding their own business, but then they get a little too close.
Uh-oh.
Their gravity snags them, and they get locked in this gravitational embrace.
Wow.
And this happens a lot in star clusters where it's super crowded.
Makes sense. More chances for a stellar meet cute in those crowded cosmic dance floors. So that's two ways. Any others?
One more: accretion disks.
Those are the disks of gas and dust that swirl around young stars, right?
You got it. And sometimes this disk can become unstable. A chunk of it breaks off and collapses to form a second star.
So it's like a stellar sibling rivalry. Two stars born from the same cosmic womb.
Yeah.
Fascinating. But are these relationships always harmonious? Having two stars so close together sounds like a recipe for some pretty intense situations.
Harmonious. Not always. Let's just say binary star systems can be a bit dramatic.
Dramatic how?
Well, think about a star that's nearing the end of its life. It puffs up into a red giant.
Right.
And if it has a companion star that's close enough, well, things can get interesting.
Interesting how?
That red giant can actually start dumping its outer layers onto its companion.
Whoa, like a cosmic vampire.
Yeah, it's called mass transfer, and it can really shake things up.
So what happens to the companion star? Does it just get bigger and bigger?
It can, but it can also start spinning faster and faster, sometimes even erupting with bursts of energy.
Wow, so one star's ending can actually fuel the other star's craziness.
Exactly. And sometimes this whole mass transfer situation can trigger something even more spectacular: a supernova.
Oh, wow. I thought supernovae only happened when a single massive star dies.
They can, but binary systems have their own way of creating supernovae, especially what we call type Ia supernovae.
Right, you mentioned those earlier, something about a white dwarf star.
Exactly. So a white dwarf is the super dense leftover core of a star like our sun. And in a binary system, it can start pulling material from its companion.
So it's like the cosmic vampire situation, but with a white dwarf.
You got it. But here's the thing. A white dwarf can only handle so much mass. There's a limit.
A limit.
Yeah, and if it goes over that limit, well, boom.
A supernova?
Yep, a type Ia supernova, one of the most powerful explosions in the universe.
Incredible. But wait, you said these type Ia supernovae are important to astronomers. Why?
Because they're like cosmic lighthouses.
Lighthouses.
Yeah, they all explode with the same intrinsic brightness. So by measuring how bright they appear to us on Earth,
I can figure out.
how far away they are, it's like a cosmic measuring stick.
That's so clever. So these explosions are actually helping us understand the vastness of space.
Exactly. They've been crucial for things like mapping out the expansion of the universe, even figuring out stuff about dark energy.
Wow, so binary stars are more than just pretty lights in the sky. They're like these cosmic laboratories. But after a supernova, what happens to the stars themselves? Are they just gone?
Well, it depends. Sometimes one star might be completely obliterated, leaving its companion to wander the galaxy alone.
Oh, sad.
But sometimes something even more mind-blowing can happen, especially when you're dealing with massive stars.
More mind-blowing than a supernova. Okay, you've got to tell me.
Imagine a star so massive that even a supernova can't completely destroy it. Its core collapses even further, squeezing itself into an object so dense that it warps the fabric of space-time.
Wait, are you talking about?
Black holes. Yep,
Yeah.
those regions of space-time where gravity is so strong that nothing, not even light, can escape.
Wow, so binary systems can create black holes.
They can. And sometimes these black holes can actually stay bound to their companion star.
So even after a supernova, the relationship can continue.
Sometimes, yeah. And those systems are called X-ray binaries.
X-ray binaries. What makes them so special?
Well, picture this. You've got the black hole with its incredible gravity pulling in material from its companion star.
Okay.
This material swirls around the black hole, forming what's called an accretion disk. And as it falls in, it heats up to millions of degrees. That's when the X-rays come in.
So it's like a black hole with a giant cosmic spotlight shining X-rays out into space.
Pretty much. And by studying these X-ray binaries, astronomers can learn a lot about the physics of black holes, which, let's face it, are still pretty mysterious.
They are.
Yeah.
So we've got these binary systems creating supernovae, birthing black holes. It's mind-blowing. But amidst all this chaos, I have to ask, can planets even exist in these systems?
You would think that the gravitational forces in a binary system would make it impossible for planets to form or survive.
Yeah, it seems like it would be pretty unstable. So is that the case? No planets in binary systems?
Actually, you'd be surprised. We've found planets in binary star systems.
Really?
For real, yeah. They're called circumbinary planets, and they orbit both stars, like they're dancing with two partners at once.
Wait, so are we talking about planets like Tatooine? You know, from Star Wars?
Yeah.
With the two suns in the sky?
Exactly like Tatooine. That was actually inspired by the idea of circumbinary planets, and now we know they're not just science fiction.
Wow, that's incredible. But how do those planets even form and stay stable? It seems like the gravity from two stars would make things pretty chaotic.
It's definitely a challenge. It really pushes our understanding of how planets form. But we're finding that circumbinary planets can form from the material left over after the two stars are born.
So there's still enough stuff left over to make planets, too.
Yep. And if the conditions are just right, their orbits can actually be quite stable.
So they're not just getting tossed around between the two stars.
Nope. They find that sweet spot where the gravity from both stars balances out.
That's amazing.
Uh-huh.
So we've got planets orbiting two stars, stars creating supernovae, stars collapsing into black holes. Binary systems are so much more than I ever imagined.
They really are. And all of these amazing events, they actually have a huge impact on the evolution of galaxies.
Okay, tell me more about that.
Well, remember those supernovae we were talking about?
Yeah, those massive explosions.
Right. Well, those explosions don't just create pretty light shows. They also scatter all kinds of heavy elements out into space.
Heavy elements. You mean like the stuff that makes up planets?
Exactly. Things like carbon, oxygen, iron, the building blocks of everything.
Wow.
And then those elements get recycled. They become part of new stars and planetary systems.
So binary stars are basically enriching the galaxy with the ingredients for, Well, for everything.
Pretty much. Without them, the universe would be a much less interesting place. And it's not just about the chemistry.
What else do they do?
Binary stars can really shake things up in terms of a galaxy's dynamics. Think about it, you've got these two stars orbiting each other,
Okay.
and then they encounter other stars in the galaxy. Those gravitational interactions can cause all sorts of chaos.
Chaos like what?
Well, sometimes stars can get flung out of their original star cluster because of those encounters with binaries.
So like a gravitational slingshot.
Exactly. And those ejected stars, they carry their heavy elements with them, spreading them out to new parts of the galaxy.
So binary stars are like these cosmic gardeners, helping to seed the galaxy with the stuff that makes planets and life.
That's a great way to put it. It's really amazing to think about how much impact these systems have on the universe as a whole.
I know, it's mind-blowing. Well, this deep dive into binary star systems has been truly incredible. We've learned about their formation, their different types, the mind-boggling phenomena they create, and the huge impact they have on galaxies.
It's been a wild ride through the cosmos, that's for sure.
And I'm feeling very inspired to keep learning more.
There's always more to explore.
That's the beauty of space, right? There's always something new and amazing waiting to be discovered. So to all our listeners out there, if you want to join us on more of these cosmic adventures,
Follow and subscribe to Cosmos in a Pod's podcast and YouTube channel for more fascinating insights into space and science.